So let's mess around with VTP. At the moment, show VLAN brief shows me VLANs on the switch. It's got VLANs 1 and 2 currently configured. Show VTP status. It's a very bad idea to use VTP. Generally, you should use transparent mode. VTP can be manipulated, and that's what we're going to do here. Notice it's using the default operating mode of server. It's in the VTP domain called Cisco. The last configuration was done by this IP address, in other words, the local switch. So press G to change the attack protocol. Let's change the protocol to VTP or VLAN trunking protocol. We can see that a summary VTP message was sent by the switch. The domain is Cisco. X for execute. Let's send a VTP packet to the switch. Notice request information was sent to the switch, summary information, and a subset of VTP message was received from the switch. So we are interacting with the switch using VTP, and that's possible because this interface was turned into a trunk using Yersinia. Okay, so again, show VTP status. Switch is configured to be a server, show VLAN brief. We've got these VLANs configured on the switch. Notice what happens when I create a VLAN 3. The Yersinia application shows us on the Kali Linux host that information was received. If we look at the subset, notice we can see the revision number on the switch. So, show VTP status. Revision number is currently 40. If I create another VLAN, let's say VLAN 4, that should change the VTP status. So show VTP status. Notice the configuration revision number is 41. Yersinia crashed there on Kali Linux. But I'm going to use G once again to specify the protocol. This is one of the reasons why you might want to install Kali Linux rather than booting it off the DVD. And you also might want to shut down these interfaces that are flapping. So G, specify the protocol, VTP. Let's create another VLAN. So VLAN 5, exit. Show VTP status. We're at 42 now. Go to subset. Notice revision number is 42. Okay, so let's execute something. Let's add a VLAN. So I'm going to add VLAN 10 rather. And let's call this hack 10 and press enter. Now I've found that it won't work unless I do something. Notice VLAN 10 doesn't exist. Type VLAN 6, however. Notice we see something happening here. Show VLAN brief. Notice VLAN 10 now displays in the VLAN database. VLAN 6 is also there. Basically, if you create VLANs here, it speeds things up. So rather than waiting a long time for something to happen, do something on your switch to initiate messages between the Kali Linux host and the switch. So G, VTP. So X for execute. Let's add another VLAN. So 3 for a VLAN. I'll make this 11. And let's call this hack 11. Press enter. Back on the switch. Show VLAN brief. We don't see 11. But if I created a VLAN 7 and then exited out of that to get some traffic going between the switch and the Kali Linux host, notice VLAN 11 exists in the VLAN database. So I've essentially used Kali Linux to add VLANs to the VLAN database of the switch. Again, the reason for doing something on the switch is to initiate traffic and make things happen more quickly. It just means it happens quicker rather than you having to wait for something to happen. Again, show VTP status. Notice revision number is set to this. It's 46, but notice the difference here. This VTP server was configured by Kali Linux. Notice funny IP address, funny message. Previously, the VTP status showed us that the local switch configured the VLAN database, but now Kali Linux has configured the switch.